Hey, good afternoon. I hope that you all are staying warm and dry on this crazy icy day. I wanted to walk through just a couple more examples of L'Hopital's rule. If you remember yesterday, we had indeterminate forms. So if we have a form where we're looking for the limit of something, so let's say f of x, and we have the situation where we have 0 over 0 or infinity over infinity, or negative infinity over negative infinity, we can look at the derivatives of the two and solve our problem. So here I have the first example. The limit as x goes to 0 of e to the 2x minus 1 over sine of x. And so e to the 0 minus 1, if we just do direct substitution over sine of 0, gives me 0 over 0, right? So we do have our indeterminate form. And the first thing that we want to do is take the derivative of the top. So now we're going to look at limit as x goes to 0. We have e to the 2x, and then we need to multiply by the derivative of that exponent, so that would be times 2 minus 0 over cosine x. And so I can rewrite this, clean it up a little bit. I get 2e to the 2x over cosine x. And cosine of 0 is 1, so we no longer have the 0 in the denominator. And then e to the 0 again times 2 gives me 2 times 1, which is just 2. So that one's pretty straightforward. Scroll down a little bit. Maybe. There we go. And I have a new question. So now I have one that has an indeterminate product. So this question, we have x squared and e to the negative x. So this looks like a product, and we're looking at as x goes to infinity. We can rewrite this. Sometimes we can take a product and rewrite as a quotient. So keep in mind, if you're looking at something that's a product, you might be able to rewrite that as a quotient. So here I'll rewrite this as x goes to infinity. We have x squared, and this is e to the negative x, so I'm just going to drop that down to the bottom. So now we have this in this nice quotient form. All right, we know e to the x and x squared are both continuous. And so let's take the limit as x goes to infinity. We also know that x squared and e to the x, if you head off to infinity with x, would be an infinity over infinity situation. So we're not finished yet. So we need to do 2x over derivative of e to the x is just e to the x. Again, 2x as x goes off to infinity will give us infinity. And e to the x will take us to infinity. So we're going to run it one more time. Let's take the derivative one more time. So I have limit as x goes to infinity. Now I have 2 over e to the x. And now we're in a good position because that 2 in the numerator gives us an actual solution. So as e to the x gets bigger and bigger and bigger and bigger and bigger, our function itself goes to 0. Remember, if we have a fraction and the denominator is getting larger and larger and larger, then our limit goes to 0. The last one I want to look at today, I have an indeterminate difference situation here. So I'm subtracting two things. And so this is tangent of x minus secant of x. And we're looking as x approaches x over, or pi over 2, I'm sorry, pi over 2 from the left. And so I went ahead, if I can get my toolbar that usually pops up for no reason and now will not pop up. 1 second. I went ahead and graphed those two. Come back. There we go. I went ahead and graphed. Oh, there we go. I went ahead and graphed tangent and secant of x so that we could see what's happening. And so if we look, here's tangent x in the red. This is our pi over 2 here. And then secant are these U-shaped parts of the graph. And that's in blue. And so as we approach pi over 2 from the left, both of our functions are going off to infinity. So here I have, find where my pen is. So the limit here, as x goes to pi over 2 from the left, would be infinity. Oh wait, hold on. That shouldn't be left. That should be, let me fix that up. All right, let's see if I can fix it. From the left would be essentially infinity minus infinity. So the question is, which infinity is bigger? Well, we don't really know. So again, we're in this indeterminate form. And so what we want to do here, we want to think, how can we make tangent and secant into something that is a quotient? Well, we can take this and we can rewrite it as x approaches pi over 2 from the left. I can write this as my sine over cosine minus 1 over cosine x. Right? And we see here we have the same denominator, so we can combine that into one fraction. We have limit as x approaches pi over 2 from the left of sine x minus 1 over cosine x. And so I think to myself, what does my unit circle look like at pi over 2? This sketch here, more of an ellipse than a circle today. It's a little flat, but you get the picture hopefully. So this is pi over 2. And my cosine here is 0, and my sine is 1. So here, if I just use direct substitution, sine was 1, so that gives me 1 minus 1 over in the numerator, and then cosine of x is 0, so I get that 0 over 0 indeterminate form. And so again, we want to solve this by L'Hopital's. Take the derivative of the top and the bottom. And here I end up with cosine of x. The negative 1 just goes to 0, or goes to 0 when I take the derivative, over negative sine of x. And now I have the reverse, right? So I have cosine of x equal to 0 over sine of x, which is negative sine of x. And that gives me 0. So as long as I have that constant in the denominator with the 0 on top, I'm fine to direct substitute and leave that as the limit being 0. All right, so I hope that is a quick review and a help for you on the homework assignment. Please email if you have any questions that I can help with. I will be around tomorrow morning if anybody has any questions or needs any help. Thanks so much.